So, Helio College Math students, part of the linear modelling unit is going to involve you guys understanding break-even analysis, particularly in a business situation where a company will have cost and revenue. So if you're running a factory and you're producing products, for instance, producing some sort of item, then it's going to cost money for the materials, the labour. If you're using electrical components in the factory, that's going to cost money. But then you get to sell those items and you have revenue. So we need to understand some linear algebra in order to do cost and revenue analysis and find the break-even points and determine when are we going to start making a profit and whether or not a business will be feasible. And that's going to involve finding a point of intersection between two lines. So we have the equations of two lines here. We've got our y equals 2x plus 5, take 5, and we have y equals negative 3x plus 10. Now, we don't need to do this every single time, but I'm just going to draw these lines in the plane, the Cartesian plane. Okay, so the blue line, a really quick rough drawing, not using a ruler because it's too hard on my tablet to use a ruler. 2x take 5 will look something like this. Cutting here at negative 5 and at 2.5 up here. And the red line for the other equation will look something like this. Oops, not like that. That's not very good, is it? It's got to be straighter than that. So perhaps something like this. Cutting here at 10 and at about 3.3. Okay, now the whole issue, or the whole crux of this, what we want is to determine this point of intersection. The x and the y coordinate point at that point of intersection. Where do the lines cross? So this is how we do it. Step 1 is to make the equations equal to one another. So we take this 2x take 5 and we make it equal to our negative 3x plus 10. Now the reason for this is because we're assuming that we get the same y value, or the y value will be the same at that point there. So this y will be the same as this y, and hence the left this equation, this part of the equation will be equal to that part of the equation. Let's not get into that too much. Just remember, let's make the two right-hand sides equal like that. Now this looks really similar to some algebra you've done earlier. And what I explained was that we make the x's go to the left side of the equal sign and numbers go to the right. Righto, so I'll just erase that so that there's, I'll erase that in a moment actually. Let's do this. So this negative 3x is going to come over this side, and this negative 5 is going to come over to this side. So this looks like this. Let's put that back there. Oops, that's not what we want. Okay, so what we end up with is 2x and we take 3x. So that's that. Beg your pardon, we do plus 3x. So that is this negative 3x coming over and becoming plus 3x. And this equals, we've got our 10 there, and this negative 5 comes over and becomes the opposite, which is plus 5. You guys have done this previously in this unit. Things that looked like this, equations that looked like this. So there's our plus 5. Now you might want to pause the video at this stage and go ahead and try and solve this and find a value for x. Then I'll have a go at it. Okay, I'll try it now. So on the next line, we add all these x's on this side. 2x and 3x makes 5x. And that is equal to 10 plus 5, which is 15. And so the last step is to solve for x. This 5 is multiplying on this side, so we take him over and he divides. So x equals 15 on 5, which is 3. So we've got our x value. It's 3. Now I'll put it up here. We'll get rid of all this. We know that x equals 3. Alright, so we're halfway there, and we've done the hard part really. Now what we need to do is find the y value, because we need the x and the y value for the coordinate point. So to do that, we substitute it into the two equations that we had before. We know that y equals 2x plus 5. Well, x is actually 3. So we're going to put that there. 2x take 5. And we also do it into the other equation as a double check. Y equals negative 3 by, well, x is 3 plus 10. So I've substituted my x value into both the equations here and here. I've put that in there and there. So then we do 2 by 3 is 6, take 1 equals 1. 3 by 3 is 9 and negative 9, because that's a negative. So negative 9 plus 10, which is also 1. Now, if those numbers ended up being different at this point, then something's gone wrong. They must be the same, because you're finding the y value and there's only one y value and one x value at that point. So the final answer is that x y equals, well, the x value is 3 and the y value is 1. So that's our coordinate point. Okay, I'm going to have a go at the next one here and go through it fairly briskly, but you might want to pause the video and try it on your own first and then see the answer that I get. Okay, I'm going to do it now. So first I make those equal. For negative 4x plus 6 equals 2x take 12. And then on the next line, negative 4x, I'm going to bring that 2x over and get negative 2x equals negative 12. Bring that positive 6 over and make negative 6. So that means negative 6x equals negative 18. So x is negative 18 over negative 6, 3. So we put that into the two equations. Y equals negative 4 by 3 plus 6, and y equals 2 by 3 take 12. This one, negative 12 plus 6, which is negative 6. So we should get negative 6 again here. 6 take 12. Did it work out? You bet it did. Negative 6. So our final answer here is x and y are (3 and negative 6). And there's our final answer. Okay, so go ahead and look at the questions in the description for the video and try those. Now, algebraically, this is about as difficult as it's going to get this year in these particular types of questions. This is tricky and it may take quite a bit of work. As usual, I'm there in the room with you at school, so get me over to give you a hand with these, because there are lots of steps and it does take quite a bit of time to get through them, and it's going to take some practice. You just got to work at it. Okay, go and try those questions.